engineering challenges make solar energy economical, presented by Group 15. So what is solar energy? Solar energy is energy from the sun that is harnessed in order to use a wide range of technologies. We all know that solar energy is a renewable form of energy, and it drives the functionality of multiple ecosystems. In the diagram, approximately 51% of all incoming solar energy is absorbed by the land and the oceans. Therefore, in order to create electricity from solar energy, we would require to use a photovoltaic cell. So the photovoltaic cell, or a PVC, as denoted in the diagram to the right, receives photons from the light, and these photons excite electrons in the p layer of the silicon, which move to the n layer, conducting electricity, and these electrons are this electricity is then given into the load. So we often talk a lot about sustainability. Sustainability, as we know, is the process of designing or operating systems such that they use energy in a more economical way and do not exploit non-renewable resources. And exploiting these non-renewable resources can be demonstrated in deserts and where there's a dependency of oil and gas. And using solar energy can reduce these dependencies. And as Dr. Neisel defined sustainability to be compounded within the constraints of time, cost, and quality, we believe that solar energy would fit into these constraints, and these constraints are talked within the statistics of efficiency, where we can see, for example, the CPV produces a theoretical maximum efficiency of 63%, and a best research cell an efficiency of 43.5%, and a typical modular with an efficiency of 31%. And this sort of decreasing trend is portrayed in every single cell, where we see that the actual efficiency is very small compared to the theoretical efficiency. So this raises a problem at hand. So the problem over here is obviously a low amount of efficiency, and we obviously need to distribute this energy into less fortunate areas, and it's only solar energy contributes to only 1% of the world's total energy, where we humans can do much more. Therefore, a solution would be engineering, out of which chemical engineering is one of the biggest booming aspects, where chemical engineers, as we know, involve in constructing large-scale mechanisms from small-scale chemical reactions. For example, we see in the field of solar energy that combining dye molecules and titanium dioxide help absorb sunlight better, and in this way, creating such materials take into account the spectroscopic properties of certain materials, where we can create tandems or multiple materials fused together in order to absorb wavelengths of lights from UV to IR. And because we use a lot of materials, this raises the concept of material engineering, where materials engineers are involved in researching, developing, and designing materials to improve technologies and finding better combinations. For example, we see that materials engineers use these tandems in order to create an efficiency that is much greater. For example, a 46% efficiency using a tandem compared to 25% efficiency without using it. And in this way, we see that the dependency of materials will also raise the costs, and the cost can only be minimized by economists, where economists aim for high efficiency and lower costs. And we also see that with increasing competition in the solar industry, that the total price of these modules have been decreasing over time, where the total installations have been increasing. In this way, large firms tend to invest in the solar industry, which causes a raise in the stocks. So what is the final solution? We can see that materials engineers here determine materials, test these materials, build a prototype, and chemical engineers devise mechanisms for producing this tandem, evaluate the conditions necessary in order to maximize the engineering efficiency, thus creating the product. The economists take this product and evaluate the externalities in producing this product, and promotes firms to invest in this and identify their types of consumers. And in this way, we can subsidize the product so that it's more available to a larger number of users, thus promoting the usage of this green form of energy.